Okay, so by this point I'm hoping that everyone's convinced that there's at least one reason to care about limits. And in particular, to get your hands on the slope of a tangent line, it should be motivation enough, as we talked about in the last section. And I also promised that we would start over with the absolute basics of limits in this section, and that's exactly what we're going to do now. So the first thing I need you to be familiar with and understand is what it means for a variable to approach or get close to a value. So we're going to start with having some fixed number a. So the idea is a is some constant number, but x is a variable. And sometimes you'll write this notation. You'll write x and you'll have an arrow afterwards and it points to the a. So what this notation means is all three of the following statements that I'm about to write down. You can see here I've written it means all of the following three equivalent statements. So these are three different ways to phrase what it means to write this notation. So the first one, and this is probably the one you'll say the most often, is x approaches a. And to think about why we would use this phrase, think about what it means to use the word approach or approaches in ordinary language. If someone is approaching you, think about what that means. They're probably walking towards you and they're getting close, right? And then they don't walk right into you and crash right into you and knock you over. That means something different. But to approach something means you get close to it. Okay, so that's the first way you might phrase it. And the second statement we're going to write down is actually a much stronger statement, and this is the one I like the best because it perfectly articulates what this really means. So this is the most important one, I think. This is my personal opinion. So x gets arbitrarily close to a. Okay, and I want to do a little analogy to show you what I mean by arbitrarily close. Imagine that there's 2 points in a soccer field. Okay, there's a soccer field, there's 2 points, and I'm just going to write analogy. So you know what this is about. But let's say that this dot is you. And this dot over here is a friend. Okay, so now imagine that you've been hanging out with your friend all weekend and you like them, but you've had enough of them and you want to be by yourself. So what you're going to do, you don't mean to be rude, but you're going to draw a circle around yourself and you're just going to say, okay, I've had enough of everyone and interacting with people. I just want to be by myself and be alone for a while. So I would appreciate it if you just don't come into this circle. So you tell your friend that firmly. And you say, look, if you don't come, as long as you don't come into this circle, we won't have any problems. So they actually interpret that as an invitation to cross into this circle just to bug you because they think it's funny that you said that. So they come a little bit closer than you told them your boundary was. But that makes you irritated, but you're a forgiving person. So you've decided what you're going to do is you're going to give them a second chance and you're going to just draw a smaller circle. And you say, okay, you know what? I don't like what you did. You ignored me, but I'm going to draw a smaller circle and give you a second chance. But you better not come inside this circle. So you better not come any closer than that. Don't cross into this circle. So of course, what do? They come into the circle. And you respond by giving them yet another chance. You say, okay, fine. This is your last warning. And you draw now one more circle inside that's even smaller and say, please do not come inside this circle. I just want to be by myself. So of course, they come into that circle. You draw a smaller one. And you can see what's happening. No matter how small of a circle you draw, your friend just keeps getting closer and closer and closer to you. And maybe they never actually quite get so close as to bump into you. But nonetheless, there's no circle small enough that you can draw around yourself that they won't eventually get inside. Let's imagine that's happening. That's the situation you should imagine as an analogy. That's what it means for something to get arbitrarily close to something else. In this case, your friend is getting arbitrarily close to you. So that's what's happening with this notation. X is getting arbitrarily close to A. Okay, and then the third way you can say it, this is a common one as well, X converges to A. Those aren't the only 3 ways of saying it, but those are the 3 ways that I'll typically say it in this class. Okay, so that's what it means when you write down this notation. You're really saying all 3 of these statements. Okay, well, what might this look like in a particular example. So that's what we're going to do next. So suppose you've got a variable x, and by the way, for this course, for this to make sense, it's going to help to get in the habit of thinking of as a variable, thinking of a variable as something that can change. So a variable might be one value 1 minute, and then you turn around the next minute and now it's equal to a different value. So maybe you measure the variable x and it's equal to 2, and you blink twice and you look at it again and now it's the value 0. That's certainly possible, right? Just relax your restrictions on what it means to have a variable be certain values. They can be one value 1 minute and then change to a different value the next. So with that in mind, let's imagine that we've got a variable x and it's taking on several values. So it starts off to be equal to 1, then it's equal to 2, 2.5, and it goes through this list all the way till the end. 3.3, 3.1, 2.95, 2.99. Now that's getting fairly close to 3. And then 3.0001, well, that's getting even closer to 3. So it looks like these values are getting closer and closer and closer to 3. Now, you don't know for sure. You don't know what the pattern is when someone says ... Unless the pattern's been made clear, you really don't know what's coming next. But let's assume that this trend of getting closer and closer to the number 3 continues. And if that's the case, then this is a perfect example of a situation where you can write x approaches 3. Okay, so that's just a simple example. There's some variations on this notation up here. You can be a bit more specific in the following way. There's two variations I'm going to show you. The first one is you can write the same thing, x approaches a, but I'm going to be a bit more specific here. I'm going to put a minus sign as a superscript on the a. And what that means is just it still means x approaches a, but it's a bit more specific. It means that x approaches a from the left. Okay, so that's the first variation. And you might guess what the other variation is, but I'm going to include it anyway. You can write x converges or approaches a with a plus sign as a superscript. And that just means that x approaches a from the right. Okay, so if x approaches a from the left, what that really means is x approaches a, for starters, but it does it in a fashion that it only assumes values that are strictly less than a. So in other words, it takes values that are to the left of a on the number line. That's why we say from the left when you write this notation down. And if you say x approaches a from the right, it means that first of all x approaches a, but it does so in a manner where it only takes on values that are strictly greater than a. And the numbers that are greater than a on the number line are going to be to the right of a on the number line. So that's hence the name. Okay, so a few more examples on how we might use these variations, and this is a perfect example to point out that a perfect opportunity to point out the fact that you can do that. You don't just work with the variable x here. You can work with any variable you like. So the first example here is we've got a variable x, and it's taking the following values. You got 12, 11.5, 11.1, 11.01, getting close to 11 here, 11.0001. That's really close to 11. If it keeps on going in this pattern, then it's going to keep getting closer and closer to 11. And notice that all these values are greater than 11, right? So this is when we might write that x approaches 11 from the right. Okay, and in the next example, we've got a variable y, and what values is it taking? It's taking 4, 4.8, 4.9, getting close to 5, 4.99, 4.999. It certainly looks like these numbers are getting closer and closer to 5. So if we had to make a guess, we could say that y is approaching 5. But it's doing it from the left, right? Because all of these values are strictly less than 5. So we can say that y approaches 5 from the left. Okay, and then our third example here, we've got a variable t. What values is it taking? We've got 6, 4.2, 4.7, 5.2, still not really clear what's happening. 5.01, 4.999. Okay, maybe these values are getting closer and closer to 5. So it might be a reasonable guess to say that t approaches 5. But we can't say any more than that, assuming we're even correct. But we can't say from the left or from the right, because some of these values, like 6, 5.2, and 5.01, those are all greater than 5. And then 4.2, 4.7, and 4.999, those are all less than 5. So it doesn't really seem to be approaching 5 from a specific direction, so we would just leave it be like that. That's about as much as you can say. Okay, but I do want to emphasize too, these examples I gave you are just to give you the idea of what this notation means. They're not typically what you would be working with. You wouldn't typically be working with examples like this, but if you did see something like this, you might make a reasonable guess that x approaches 3, or that in these three cases we had x approaching 11 from the right, y approaching 5 from the left. These were all just educated guesses based on what we saw in the pattern, but you really don't know what happens because it trails off and doesn't tell you the rest of the terms. It goes on forever presumably, but you don't know what all the values are, so it really is only a guess, but we can still make an educated guess. Okay, so now you can put things together. You can write down something like this. I can say the limit as x approaches a of f of x. So you've got three components to this notation. You've got LIM, that stands for limit, and then below that just says you're talking about a limit. And then right below that notation, you'll see a variable approaching a value. And that'll be just something like what we discussed, right? And here we've got limit as x approaches a, but then we've got a function afterwards, the output values of a function. So what does this notation mean? We kind of talked about it a little bit last section, but let's nail down what this means now. This is the best way to think about it, I think. So really it represents the answer to a question. And the question is this: what happens to the values of f of x when x approaches a? So if you're just looking at this notation directly, you should say, okay, what's happening to these values as x gets very, very close or approaches this value? So what's happening to the values of f of x as x approaches a? That's really what this means, or that's what this is saying. So this is how you would unpack this notation. And we'll look at an example in the next clip, but I just want to give you a couple of variations of this notation as well. And really what it amounts to is we can incorporate these two pieces of notation into the limit notation as well, and we can make variations of this. So we can also write lim as x approaches a from the left of f of x. I'm not going to write out in words what it means, but really it just means exactly this, but if I just put a minus sign on the a here. I just change this to being more specific and saying what happens to the values of f of x as x approaches a from the left. So if I just put a minus sign here, then this statement becomes the exact meaning of this notation. And I could do the same thing from the right. I can say, I can also write the limit as x approaches a from the right of f of x, and really this just means what happens to the values of f of x as x approaches a from the right. So again, just to practice formulating this, you would just take this exact sentence, what happens to the values of f of x when x approaches a, but you just put a plus here, as x approaches a from the right, and that would give you the meaning of this notation. Okay, so in the next clip we'll do some examples of this.